Okay, everybody can see my screen.
Yes.
Or no?
Yes, yes.
Okay.
We can see it and we can hear you also. So,
thank you.
Our next speaker this morning for us here in Argentina is Mariana Coutinho from Universidade de Sao Paulo, Brazil. And she's going to talk about on the generalized Suzuki curve. Thank you.
Thank you very much, Maria. First, I would like to thank the organizers for this opportunity. And I started this talk with some notation that will be used in the whole presentation here. So let P be a prime number, Q0 a power of this prime, and Q is related to Q0 as Q is equal to Q0 squared over P. Also, we fix the finite field FQ to the M, and we consider the algebraic closure of FQ, and we denote it by FQ bar. And also we consider this point of the projective plane, the point 0, 1, 0. The curve that will be interested in this talk is the projective plane curve with this equation given a finite coordinate. And in a first moment, we aren't consider the characteristic, so we can be consider both given and odd characteristics. And some properties on this curve, we have that it's irreducible over the algebraic closure, so it's geometric properties. We have also its genus given by as a function of Q0 and Q. And we have that the point P that we fixed before is its unit point at infinite, and also its singular point. These properties were studied, I forgot to mention it, by Hansen and Stitinoff for the even case, and by Garcia and Stitinoff for the odd case. So we'll now consider the non-singular model of this curve, and we'll denote it by X. And we'll want to fix some notation. We'll consider the function field of this curve X with generators X and Y, which satisfy the polynomial equation of the curve G. And as a standard notation, we will consider the number of FQ rational points denoted by NQ to the M. If you consider the even characteristic, this curve, that X is the so-called Suzuki curve, and it's a well-known curve with several properties. And the first one that I would like to highlight here is that this curve is maximal for certain extensions of FQ, and the number of rational points on this curve is presented by this result due to Hansen, proved in 1992. So here is the full description for the number of rational points of X. In this case, this is a curve. And I highlighted the two cases here, the first and the last one, which provides the cases in which this curve is maximal and minimal with respect to the Hasse-Weil bond. The Suzuki curve has other properties that are interesting. So we have, for instance, the optimality in the sense that the number of FQ rational points of this on the Suzuki curve coincides with the maximum number of FQ rational points that a curve of genome can have. We have a characterization for the Suzuki curve based on its number of FQ rational points and the genes. Also, we have perhaps one of the most interesting properties that this curve have a large automorphism group with respect to the genus. Being more specifically, we have that this curve is one of the 4 curves with automorphism group greater or equal to 8 times G cubed. And the other studies on the Suzuki curve go through, for instance, the investigation of the general and the plane models for some quotients of this curve embedded into other space, class field theory, the number, the Weierstrass sum groups, and also folder theory. And now, if you will consider the odd characteristic case, we'll change the notation. So we aren't dealing with the Suzuki curve, but now we call the generalized Suzuki curve. And we can ask some natural questions on this curve. Some works have already studied this curve in terms of Weierstrass sum group at the point at infinite, and the codes, some codes on this curve, and also in terms of abelian, elementary abelian extensions, since this curve is an example of such function field. The main properties that will be interested in this talk will be the number of rational points on the generalized Suzuki curve, and also the automorphism group. And since you know the number of rational points, we can also ask about the polynomial of this curve, and it's the main part of our work. The first result that we have in this direction is, and the first result is on the number of rational points, and so we got a full description on this number. And if you look at this first part here, we can check the cases in which this curve is maximal or minimal, and it will depend on the characteristic. So there are cases in which this curve is only minimal. We don't have any extension in which this curve is maximal, and in others we have this in here. And to present one clearly, for instance, we have that the curve, the generalized Suzuki curve is maximal if P is equivalent to 3 mod 4, and in the case we to consider the extension 2 times p. So I'll not present the full proof of this result, but I'd like to present an outline and some ideas. And what we did in this case is I like to separate it in 7 steps. The first 3 of them deal with the situation to change the problem of computing the number of rational points on X to another problem to compute the number of rational points in another curve that I call here a sample curve. And after that, we can actually compute this number of rational points in the simple curve, but up to a sign. And at the final step, we determine the sign in the previous expression. So the first 3 steps, we deal with, we consider the subfields of the elementary abelian extension. And then we compute the number of rational points on these subfields. And before doing this, we consider some isomorphisms on it. And so in not computing man in man of the subfields, but the only one. The second part here, where we determine the number of rational points in the simpler curve, we use quadratic forms to make this work. So we have some references to do this. And the last one is we have 2 steps. The first one we consider a subcover of the generalized Suzuki curve, and then other one we consider a result that is provided in this paper here. And here I put the basic reference for our calculation of this theorem. And once we have the number of rational points, as I told before, it's natural to consider the polynomial to ask if you can provide a full description of it. And so, yes, the answer is yes, we can provide this description. And once we have the number of rational points, the idea of the proof is only to consider somewhat the basic definition that associates the roots of the reciprocal of the polynomial to the number of rational points. And considering this relation and playing a little bit with some roots of unit, we can provide these expressions here. And finally, to be end with the full description of the automorphism group of the curve X, which is here the generalized Suzuki curve. And so we have that it has order q squared times q minus 1. and it's given by these maps here. Also, we have a description of the group as a semi-direct product of a group G1. It's the Silo-Pisugbu subgroup of G. We do have a description of it. And also we consider, we have the complement of the Silo-Pisugbu subgroup, and we have this. They have the maps have this shape here. The idea is not too hard to understand. It first we consider the stabilizer of the point at infinity, and we prove that this stabilizer is given by these maps here, and the one direction of this equality is easier. It's provided by a direct computation. The other one uses some properties on the Weierstrass sum group of at p infinite. And once we have the stabilizer and the first ramification group, and we have the order of this subgroup, we only apply this result, which states that if the first ramification subgroup has order greater than 2 times the genus plus 1, then, or the full automorphism group is equal to the ramification, the stabilizer at a point, or the curve is variational equivalent to or the Hermitian, either to the Hermitian, Suzuki, or the recurve. And so this ends this main 3 talks that we analyze. And I would like to ask, to end this talk, ask which other aspects can be studied too for the generalized Suzuki curve, and perhaps codes, variational impedance, Galois extensions, other aspects. So, and I would like to point out here that the characteristic in the case of the Suzuki curve was very important in many of the aspects that were proved for this curve. So when we try to extend these results to the case of the generalized Suzuki curve, it's not so easy to transfer these results, but this is good because we need to develop other techniques and the other results, other machinery to do this. So thank you very much for your attention.
Thank you. Thank you, Mariana. Are there questions or remarks? Well, I want to make a question also, but I don't want to speak too soon. We have a question in the chat. Adam says, are there unramified covers that have nice equations?
Well, I don't think about this yet, but it should be.
Okay.
Another
Adam,
question.
I don't know if you want to put your microphone or not, if that's.
Oh,
No?
sorry.
Thank you. Okay, I have another question now. When you calculate all the number of rational points, well, you have these cases in which it's maximal, so it is the best that you can have. But for the other cases, have you checked if at some examples for some specific genus, for example, you get a better amount of points? That's the one that are in this database, which is called manypoints.org.
Okay. I've tried to do that, but we have that the genus large quickly. So there is only one case that we could check is when t is equal to 1, and there no, we didn't get anything good.
Anything better than the one, yeah.
Yeah.
So I was thinking of that because since you have exactly the exact amount of that, it would be good. And another is not a question, but I think that since you have this nice form that you have already calculated the automorphisms group, then you should go for the coding theory part and try to do something, because now that you have the stabilizer of that of that point, then you can make many nice computations. So is this work published or on our archive?
Yes, yes. But it's available in archive too.
Okay. Well, if there are no other questions, then let's thank Mariana again. And now we have some minutes before our next talk for the other Mariana. Hello. I think that we have Brazilians and Argentinians today in our session, even if they are not on Brazil or Argentina right now.
Congratulations on winning the Copa America, by the way. It pains me to say that, but you guys did well.
Well, but we need it.
Yes, it would be a shame if Messi retired and didn't get like an.
Yes, of course.